All right, so I wanna have a smaller margin of error here. So let's try and fix that. I gotta increase the sample size. So let's say I go from 40, I'm gonna go for 100 people. So now Gary surveys 100 Umatilla County adults. And finds 23 are fully vaccinated. So what's going to happen here? So I'm just going to first jump right to the central limit theorem. So the central limit theorem says that the margin of error for this situation right here is going to be the magic z-score that we choose times the standard error. Standard error for a proportion is that funky square root of the sample proportion times the opposite of the sample proportion over the sample size. Now, we usually go for a 95% confidence interval, a confidence level. So for a 95% confidence level, we've seen a few times now, that means the z-score is going to be to 2 decimal places 1.96. If we need more decimal places for that, we have to ask a spreadsheet. And in the next example, I'll show how to do all of this on a spreadsheet, including find the z-score. Otherwise, I just plug that in from my margin of error. So now I have that right there, 23 out of 100 is my p-hat. So I take my z-score, 1.96, and then I got this funky square root. First, in the top of that square root goes my 23 out of 100, which is 0.23. And then 1 minus that 0.23. It's all inside the square root there, divided by the sample size, which is 100 there. And we just whip out a calculator to figure out what that is. I'm going to do the standard error separate just for fun, because we're going to check that in stat key in a minute. I'll jump over to Desmos here. So standard error would be the square root of the fraction 0.23 times parentheses 1 minus 0.23. So you could just, I did the minus ahead of time before, you could just throw it in the formula as long as you use parentheses properly. And my sample size is 100. So in this case, the central limit theorem says my standard error should be about 0.042. I wanted 5 decimal places, 0.8 after that. So this should be an approximate because that's an approximate right there. So now I have 1.96 times 0.04208. Is that right? Yep. All right, and then we just multiply. Back to the calculator. So that previous, and I guess I'll just rewrite it, 1.96 times that 0.04208. And this says I should have a margin of error about 8%. That's better than 12 or 13% I had before. So 0.08248, 0.8248. So now for my confidence interval, isolate this. So my confidence interval. One way I could state it is by just saying it's centered at p hat, right, plus or minus our magic z-score times the standard error. This right here is our margin of error, right? So p hat plus margin of error. My p hat is 0.23. My margin of error is 0.08248, plus or minus. Usually we state that as an interval, parentheses lower, comma, upper. So we need to calculate those. 0.23 minus that 0.08248. So 14.752%. Do that with a plus. Plus, Gary, please. There we go. I'm just going to put it over for a second so I can write it down. So we think, according to this new central limit theorem version, that it's somewhere between 0.14752, about 14.8%, up to about 31%, 0.31248. So I definitely got a smaller margin of error because I increased the sample size. So I have a margin of error of about 8. When I did the sample size of 40, I ended up with a margin of error of 12, almost 13, which is pretty high. Double check with StatKey to see if StatKey agrees on the standard error and this interval. It won't be the same, but it should be close. So if we go over to StatKey, confidence interval for proportion, we enter our data, which this time is 23 out of 100. StatKey says that's 23%, running thousands of samples. I'll do 8,000 like before. StatKey ends up with a standard error of 0.042, which is what we calculated right up here, about 0.042. And for a 95% confidence interval, StatKey says it's going to be around 15% to 31%. And that is pretty close to what we have. 14.75% is close to 15%, and 31.2% is close to 31%. So the simulations will be a little bit different, but they should be in the ballpark in terms of the standard error, this guy here, and the confidence interval, and the margin of error. All right, so again, what's the point here? Couple things. We have this new formula from the central limit theorem that we can use. We have this idea about another way to calculate the standard error, which gives us a margin of error. And the third idea is that if we increase the sample size, that's going to decrease the margin of error. So we'll get a smaller margin. But then there's the cost of increasing the sample size. So what if somebody says, man, 8%, still too big. Still too big. You need a smaller margin of error that you need to sample more people. Well, right now it's kind of a guess and check. Well, how many people do I need to survey? And someone comes back and says, you need a margin of error of no more than 3%. Okay, fine. No more than 3%. So how do I figure out how many people I should interview for a margin of error of 3%? Well, it turns out we have everything we need to do that right here. Coming up next.